October 1916. A British machine gun crew sits in a forward trench on the Somme, their Vickers gun trained on a gap in the German wire 400 meters distant. The gun has been firing continuously for 12 hours. The water in the cooling jacket boils away every 40 minutes and is replaced with whatever liquid is available. Tea, urine, contaminated shell crater water. The gun continues firing. By dawn, it has discharged over 100,000 rounds. The barrel glows dull red in the darkness. The crew pours more water into the jacket. Steam rises in thick clouds. The gun does not jam. It does not break. When the attack order finally comes and the firing stops, the crew inspects the weapon. The barrel is worn but functional. The mechanism shows no signs of failure. They reload and prepare for the next fire mission. The Vickers machine gun would fire another 100,000 rounds before the war ended, and it would do so without a single mechanical breakdown. This was not luck. This was engineering. The British Army entered World War I with a machine gun problem that was doctrinal and technological. The Maxim gun, adopted in 1891, was effective but extraordinarily heavy. The standard cavalry model weighed 57 pounds without its tripod or water. Mobility was poor. Cooling was inadequate for sustained fire. Most critically, Maxim's toggle lock mechanism was prone to fouling under trench conditions. Mud, water, and cordite residue caused stoppages that required field stripping to clear. British military doctrine in 1914 still viewed machine guns as specialized weapons, with only 2 guns allocated per infantry battalion. By 1915, the Western Front had demonstrated this was catastrophically insufficient. Defensive positions required sustained suppressive fire measured in hours, not minutes. Existing machine guns could not maintain this rate of fire without frequent cooling breaks and mechanical failures. The specification called for a weapon that could fire continuously for extended periods, that could function in the worst environmental conditions imaginable, and that could be maintained by soldiers with minimal technical training. The answer was not a new design. It was a refinement of an existing one. The Vickers machine gun was adopted by the British Army in November 1912, but production did not reach a significant scale until 1915. The weapon was a modification of the Maxim design, developed by Vickers Limited under the direction of their chief engineer. The changes were subtle but transformative. The Vickers weighed 40 pounds with its water-filled cooling jacket, roughly 30% lighter than the Maxim. The reduction came from machining the receiver from a single forging rather than assembling it from multiple parts, and from using lighter gauge steel throughout. The mechanism remained a recoil-operated, water-cooled design, firing the standard British .303 cartridge. Muzzle velocity was approximately 740 meters per second. Effective range was listed as 2,000 meters, though indirect fire techniques pushed this to over 4,000 meters in practice. Cyclic rate of fire was between 450 and 500 rounds per minute. Sustained fire rate, accounting for barrel cooling and ammunition handling, was approximately 250 rounds per minute indefinitely. The cooling system was the heart of the weapon's reliability. The barrel was enclosed in a cylindrical steel jacket holding approximately 7 pints of water. As the gun fired, heat transferred from the barrel to the water. At sustained fire rates, the water reached boiling point within 4 to 5 minutes. Steam vented through a rubber hose connected to a condenser can where it cooled and returned to liquid form. This condensed water was poured back into the jacket, creating a closed cooling loop. In theory, a Vickers gun with an adequate water supply and ammunition could fire indefinitely without overheating. In practice, barrels wore out before the cooling system failed. A well-maintained barrel lasted approximately 30,000 rounds before accuracy degraded noticeably. By 50,000 rounds, the rifling was essentially gone and the barrel required replacement. This was considered acceptable. Barrels were field replaceable and took approximately 15 minutes to change with a trained crew. The operating mechanism used a toggle lock system similar to the Maxim but extensively modified for reliability. When a round was fired, recoil drove the barrel and bolt assembly backwards against a spring. The toggle, a hinged joint connecting the bolt to the receiver, broke upward at the midpoint of travel, unlocking the bolt and allowing it to continue rearward. The fired case was extracted and ejected. As the bolt returned forward under spring pressure, it stripped a fresh round from the cloth ammunition belt, chambered it, and the toggle locked down again. The entire cycle took approximately 1/10 of a second. The critical modification was in the toggle mechanism itself. Vickers engineers increased the bearing surfaces and improved the metallurgy, making the lock substantially more resistant to fouling and wear. The feed mechanism was similarly refined. The Vickers used a canvas belt holding 250 rounds. A pawl and feed arm advanced the belt one step per cycle, positioning the next round for chambering. This mechanism was exposed and vulnerable to dirt, but it was also simple. A stoppage could usually be cleared by manually advancing the belt one position. Training emphasized immediate action drills. Most stoppages were cleared in under 5 seconds without removing the gun from its mount. Testing of the Vickers began in 1913, but the most significant trials occurred in 1916 at the Small Arms School in Heavey. A series of endurance tests was conducted to determine maximum sustainable fire rates and identify failure points. One test involved firing a single Vickers gun continuously for 7 days. The gun fired intermittently, approximately 100 rounds every 4 minutes, with water replenished as needed. Total rounds fired exceeded 1 million. The barrel was changed every 40,000 rounds. No mechanical failures occurred. The receiver, bolt, and feed mechanisms showed wear, but remained functional. This test was not publicized during the war, but became legendary within British ordnance circles afterwards. It demonstrated that the Vickers had effectively no upper limit to its service life, provided basic maintenance was performed. Another test examined function under adverse conditions. A Vickers was submerged in mud and allowed to dry. It was then fired without cleaning. The gun functioned normally. It was submerged in water and fired while partially submerged. The gun continued to function, though the rate of fire decreased slightly due to water resistance in the mechanism. Sand was packed into the action. The gun fired until the sand was expelled by the movement of the parts, then resumed normal operation. These tests were not intended to simulate realistic combat conditions. They were intended to establish the absolute boundaries of the weapon's durability. The Vickers passed them all. Operational deployment began in 1915 as production capacity increased. By 1916, the Vickers was the standard medium machine gun of the British and Commonwealth forces. Each infantry battalion eventually fielded a dedicated machine gun company equipped with 16 Vickers guns. These companies operated somewhat independently, providing sustained fire support for battalion operations. Doctrine emphasized indirect fire. Machine guns were positioned behind the front line, firing over friendly troops at mapped coordinates. Elevation and traverse were calculated using range tables and adjusted by observers. This technique transformed the Vickers from a defensive weapon into a form of close-range artillery. Entire sectors of no man's land could be swept with grazing fire at night, denying movement to enemy patrols. On the Somme in 1916, Vickers guns fired pre-planned barrages lasting hours, expending hundreds of thousands of rounds to suppress German positions during attacks. One documented instance describes 10 Vickers guns of the 100th Machine Gun Company firing continuously for 12 hours in support of an attack near High Wood. Total ammunition expenditure was approximately 1 million rounds. All 10 guns remained operational throughout. One barrel was changed due to excessive wear. No other maintenance was required beyond routine cleaning and water replenishment. The Vickers also served in specialist roles. In 1917, it was adapted for aircraft use. The air-cooled variant, designated the Vickers Class C, removed the water jacket and relied on airflow for cooling. It was lighter but could only sustain fire for short bursts before overheating. The weapon armed numerous British fighter aircraft through 1918. The ground-based Vickers was mounted on armored vehicles, providing direct fire support for infantry. It was used on riverboats in Mesopotamia, where its reliability in extreme heat and dust proved critical. It was deployed in the mountains of Italy, at altitudes where thinner air reduced cooling efficiency, but the weapon continued to function. The Vickers adapted to every environment it encountered. Its only limitation was logistical. Each gun required a crew of 6 to 8 men to transport the weapon, tripod, water, spare barrels, and ammunition. Sustained fire consumed ammunition at prodigious rates. A single gun firing for 1 hour at combat rates could expend 15,000 rounds, weighing over 1,000 pounds. Supplying a machine gun company in action required dedicated logistics support and often a pack animal train or motorized transport. Comparison with German and French machine guns illustrates the Vickers' distinctive characteristics. The German MG08, itself a Maxim variant, was heavier and more complex, but similarly reliable. It weighed approximately 62 pounds with water and used a more elaborate sledge mount rather than a tripod. Cooling capacity was greater, allowing higher sustained fire rates, but the weapon was less mobile. German doctrine emphasized fixed defensive positions where the MG08's weight was acceptable. The Vickers was designed for offensive support, requiring better mobility. The French Hotchkiss M1914 used an entirely different approach. It was air-cooled, relying on metal fins around the barrel for heat dissipation. This eliminated the need for water but limited sustained fire capability. The Hotchkiss could fire approximately 250 rounds continuously before requiring a cooling pause. It was lighter and simpler but could not match the Vickers' endurance. For defensive fire missions measured in hours, the Vickers had no peer. The American Expeditionary Force initially used French weapons, but transitioned to the Vickers for their machine gun battalions in 1918, a decision based on observed performance rather than Allied politics. There was one vulnerability the Vickers could not overcome. The water cooling system, while effective, was also a signature. Steam from the condenser hose was visible at considerable distances, especially in cold weather. German artillery observers used Vickers' steam plumes to locate British machine gun positions for counter-battery fire. Various attempts were made to reduce this signature, including longer condenser hoses and buried condensers, but the problem remained fundamental. A gun firing continuously for hours generated steam that had to vent somewhere. The trade-off was considered acceptable. The alternative, air-cooled weapons, could not sustain fire long enough for British tactical doctrine. After World War I, the Vickers remained in British service for decades. It was used extensively in World War II, particularly in North Africa and the Far East. Minor modifications were made over the years, but the basic design remained unchanged. Production continued into the 1960s for export customers. The last Vickers guns were withdrawn from British service in 1968, replaced by the L7 general-purpose machine gun. Some remained in reserve stocks into the 1970s. Total production across all variants exceeded 200,000 units. The endurance tests conducted at Hyde were eventually declassified and became part of the military engineering curriculum. The million-round test in particular was studied extensively. Analysis revealed that the Vickers' reliability stemmed not from any single innovative feature, but from meticulous attention to tolerances, metallurgy, and maintenance accessibility. Parts were interchangeable between weapons. Critical components were over-engineered to tolerate wear without functional degradation. The weapon was designed to be repaired in the field with minimal tools. These principles sound obvious in retrospect, but were revolutionary in 1912. Most military weapons of the era prioritized performance over maintainability. The Vickers demonstrated that reliability was itself a form of performance, perhaps the most important form for sustained combat. No precise count exists of how many rounds the average Vickers gun fired during World War I. Some guns served for the entire war, firing millions of rounds across dozens of engagements. Others were lost to enemy fire or mechanical damage within months of deployment. What is documented is that the Vickers achieved something unprecedented. It made sustained suppressive fire a reliable tactical option rather than a logistical gamble. It allowed British and Commonwealth forces to conduct operations that would have been impossible with less durable weapons. It killed efficiently, continuously, and without hesitation. The soldiers who served the Vickers guns did not romanticize them. They were heavy, They required constant water and ammunition. They attracted artillery fire. But when the order came to fire, the gun fired. When the order came to continue firing, the gun continued. It did this for hours, for days, in conditions that destroyed other weapons entirely. The Vickers did not care about mud or heat or the exhaustion of its crew. It simply functioned exactly as designed until told to stop. The million-round test gun from Hyde survived the war and remained in service until 1933. It fired an estimated 3 million rounds over its lifetime before being retired to a museum, still functional.